Hi, hello, welcome to another math lesson with me. We're going to be talking about dilations today, so let's get started. During this lesson, you're going to learn how to take a line that does not pass through the center of a dilation to a parallel line and leaves a line passing through the center unchanged. This is the key point we're going to do today is take a line and dilate by the scale factor about a point. Okay, so some quick vocabulary. Dilation, it's a transformation that produces the same image but in a different size. Dilations usually include a scale factor and a center of dilation. So those two things I circled, that scale factor and center of dilation, these are the things that we're going to need to be able to accomplish our objective today. A center of dilation is a fixed point in which all the points in the image are contracted or expanded to / from. So a fixed point means it does not move. A scale factor is a ratio of the corresponding parts that are similar. So it means everything is going to be so much bigger or so much smaller. It's going to be equal. Similarity are items or images that are the same shape but different sizes. As talked about previously, we know a transformation is a shift, a stretch, a shrink, or a rotation of an image, graph, or object. All right, so dilations. They're essentially making an image grow or get smaller by a very specific number. Okay, we call that a scale factor. We're going to be dealing with lines today, and it's the big thing with dilations is it's around a point. So if I have, let's say, so for example, if I have a line that is 5 inches long, and it grows by a factor of 3, so I have a factor of 3, the new line should be I take my original line, 5, multiply it by my factor, and I'd get a 15-inch long line, okay? Now the difference between scale factors like above and a dilation is that a dilation has a central point. So remember, this is that fixed point that does not move, in which this transformation occurs around. So let's look at an example. So create a dilation of segment BC through center point A with a scale factor of 3. So I have my line here, my line CB, or segment CB I should say, and I need it to be 3 times bigger, but it needs to work around this point A right here. So what I'm going to do is to get from A to C, what I'm going to do is I'm going to start with A and say, all right, I need to go to the left 1. So I'm going to say left by 1 and down by 3. Okay? So that's what it takes for me to get from my center point to my point C. Well, I need my new point to be 3 times bigger. So I'm going to multiply each of these movements by 3. So my new point, I'm going to get to the left 3 and down by 9, okay? So now I'm going to start over here. I'm going to go, all right, I need to go 1, 2, 3, and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're down here somewhere. So we got that point right there, okay? And then we're going to do the same thing with B. So to get from A to B, let's go here. I'm going to go to the right 1 and down 1. So we're going to multiply each of these by 3 to get my new measurements. So I get to the right 3 and down 3. So 1, 2, 3, 1, 2, 3. So there's my new point. Now when I connect these up, I should get a line that's about 3 times the length of my original line and is about that center point, which this looks like it would be. So those lines are parallel. All right, so I want you to give it a try. you're going to have to plot these points. All right, so line segment AB has endpoints at A, -3, 2. So -1, 2, 3. So we have -3, 2. B's at 2, -4. So it says dilate the segment of AB through point C, which is at -1, 5. This is point C. I have this point, and I have a scale factor of 4. Okay, let's go. So I'm going to go from C to A. To get from C to A, I'm going to go 1, 2 to the left, and 1, 2, 3 down. Okay, my scale factor is by 4. So I multiply each of those by 4. So I'm going to get left 8, down 12. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, see. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew. We would call that A prime. Okay, and then to get to B, man, did I make 2 things that are off the grid? What am I doing? Okay, to get to B, I'm going to go 1, 2, 3. So let's write this down. To get from C to B, I'm going to go right 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Definitely down 9. Okay, we're going to multiply each of these by 4, which I definitely. So right 4, down 4, right? Or down 36. Goodness gracious. This is when you guys come say, hey, Ellis, your videos are wrong. So right 12 and down 36. There we go. Okay, so I'm going to go 1, 2, 3, 4, down 36. Okay, so I'm going to have to, essentially all I'm doing here is I'm adding 4 to my C component here. So that would be 3. My point, I'm looking at the point here. 3 and then down 36 from 5 would be -31. So it's going to be super down here somewhere. So all I'm doing here, because I made a point off the chart, is I have -1, 5. Right, that's my center point. Well, I need to increase it by 12 from here. So actually that's going to give me 11. So it's going to be over here somewhere and super down here. So my new point is going to be 11 and then 5, and I have to subtract 36 from it. So 5 minus 36 is a -31. That would be my new point. You could do it that way also. If you have any questions about this, please come talk to me. I know on your quizzes it's mainly just going to be around 1 point. Everything should be on the graph. Hope you have a great day, and let me know if you need any help. Thanks. Bye.